Today we'll be covering MLRun pipeline overview using NetApp AI Control Plane, the Iguazio Data Science Platform, and Kubernetes cluster setup. We integrated Iguazio and NetApp technologies to enable fast model deployment, data replication, and production monitoring capabilities in the cloud. Mr. Marcelo Litovsky will now demonstrate, starting with persistent volume claim.
The end state of the pipeline is the NetApp volume snapshot, the data prep, creating the features that are needed for the model, describe, which gives you a snapshot of the data that was used for training, a function that constantly creates features for real-time inference, then the training, and ultimately deploying the model. So this is the full pipeline that we're describing in the individual notebooks, and I'll show you at the end how the pipeline, the notebook that generates the pipeline is leveraging all the individual notebooks that we talked about. We're going to go through developing a full end-to-end machine learning pipeline using the Iguazio platform to train and build the model, and leveraging our integration with NetApp to access the data that is generated on the back end using their large capacity for storage. So first, we'll just do a quick description of Iguazio. Iguazio offers a set of managed services for AI and machine learning. Those services include all the tools that developers are used to work with for development, such as Jupyter Notebooks, Grafana, Presto for SQL. You can deploy a Spark standalone cluster, and we offer additional tools that for modern AI and machine learning development, such as an MPI operator with Horobot to do parallel do MPI workloads. We also have a backend that allows users to deploy jobs to run on our cluster, jobs that might exceed the limits of CPU and memory allocated to their Jupyter notebooks. That is part of one of our open source projects. So there are several managed services, like I said, there's Jupyter, Grafana, Presto for SQL, Spark, but we also offer a serverless framework, that serverless functions that allow you to deploy, for example, models to do inference, both in real time and in batch, utilizing triggers to trigger the execution of a function. And those triggers could be Kafka, RabbitMQ, HTTP, Kinesis. This also can be expanded because this is part of an open source project that Iguazio manages. We also have complete integration with Kubeflow, and Kubeflow allows you to develop that machine learning pipeline. All this is protected by role-based access controls, and each user has an identity that determines what resources, what services, and what policies, what things they're allowed to do within our platform. We also have a storage layer. This storage layer is not meant to be a data lake. It's not for big data. It's meant to offer data scientists the ability to do high-speed inferencing, specifically when you have models that require a big amount of feature vectors to support the model and require near in-memory access to that data to do predictions. That's a good place where you will apply Iguazio's data layer. Now, the purpose of the demo is to show how we can leverage the full storage capacities and features functionality of NetApp along with Iguazio. For that, we have connected this cluster with a volume, with a cloud volume. So if we access the cloud manager, there's a couple of things that you have to do, and we can do that through the integration between Iguazio and NetApp. First is define that association with the Kubernetes cluster. And that means that you have to provide Cloud Manager with the config file that is running for the Kubernetes cluster where Iguazio is running. That config file will allow Cloud Manager to deploy Trident and then further help you associating a volume with that particular cluster. So I already have that my cluster associated with this account. So at this point, I'm able to start working with associating a cloud volume with one of these clusters. Let me go back to the working environment. I already have this volume associated with a cluster, but if I go through the process, I already have a Kubernetes cluster defined. If I have more than one, it will be listed here. I can go through the process of connecting this cluster to creating a persistent volume to associate a cloud volume with that cluster that I had defined previously. So Cloud Manager, and through this process, installs Trident on my Kubernetes cluster, and it allows me to simply just define the persistent volume claim that I can use within my Kubernetes cluster.